Hello, in this video tutorial, I want to go over how to factor using the greatest common factor, abbreviated GCF. Let's begin by considering this example, 6x plus 13x. The term factor means the process of collecting everything your terms have in common. In this instance, we can see that the 6x and the 13x both share a common variable of x, so we can factor out that x. That's going to allow us to rewrite this expression as x multiplied by 6 plus 13. Note that if we were to distribute back everything that was factored, we should end up back to our original statement. Here, distributing the x, I would have to multiply it to both the 6 and the positive 13. X times 6 gives me the 6x, and then x times the positive 13 gives me positive 13x, and we have the original statement again. Let's consider example 2. We have 6x plus 12y. Here, the terms don't have a variable in common, but 6 and 12 are both divisible by a 6, so we can factor out a 6. We can rewrite the expression as 6 multiplied by 6x divided by 6 is 1x, plus 12y divided by 6 is 2y. And we've successfully factored out this binomial using the GCF. Now 6 and 12 do share a factor of 3 and a factor of 2, but I chose 6 because 6 was the biggest one that can divide both. Let's explore what would have happened if instead we would have factored a 2. So here, factoring the 2, we can rewrite the expression as 2 multiplied by 6x divided by 2 gives us a 3x, and then a positive 12y divided by 2 gives us a positive 6y. Once we reach this point, we should realize that we can factor one more time. The 3 and the 6, we can divide both of them by a 3. So let's go ahead and factor out a 3 as well. And now 3x divided by 3 gives us a 1x. And then a positive 6y divided by a 3 gives us a positive 2y. And the factors that are outside of the parentheses multiply together, giving us a 6. And you can see that we get the same result. Let's consider example 3. 5x cubed plus 7x to the 5th power. 5 and 7 don't share any common integers besides 1, and we typically don't factor out the 1. But they do have a variable in common, the only difference is the powers. Now we take a look at the smallest one, and that determines how many copies of that variable we are allowed to factor. So here I'm going to factor out the x to the 3rd power, leaving me with a 5 plus a 7, and now we subtract 5 minus 3, leaving us with 2 copies of x, or x to the 2nd power. I want to conclude this tutorial by looking over one final example. Example 4, negative 8x plus 12x squared. First, we are going to look at the coefficients 8 and 12, and we have to decide what would be the greatest common factor. After a few moments of thinking, we should come to the conclusion that we can factor out a 4. Notice that there's a negative in front of the 8, so I'm actually going to be factoring out a negative 4. And negative 8 divided by negative 4 gives me a positive 2x. And then a positive 12x squared divided by a negative 4 gives me a negative 3x squared. Now I am going to focus on the variables. We have a common variable of x. Here, I can specify the power. This is power of 1. And if I take a look at the exponents, I see that my smallest exponent is 1. I'm going to factor out an x to the 1st power. We have negative 4 multiplied by the x to the 1st power. And now we are left with 2 minus 3x. We combine the factors here on the outside of the parentheses, giving me a total of negative 4x multiplied by 2 minus 3x. And that would be the final factorization. Now would be a good time for you to practice. Try this set of exercises, click pause and see if you can solve them. And if you found this video helpful, please give the video a like. Also make sure to subscribe and hit the bell to be notified when I drop new content. The answers will present themselves in 3, 2, 1. Have a nice day, and I will see you next time.